Hello everyone, this is Jay from BTYT Tech Library. Today we are going to externalize the data storage to a PostgreSQL database on the application that uses in-memory data we built together last time. Are you ready? Let's code along. First, let's quickly check on PostgreSQL. PostgreSQL is a powerful open-source object-relational database system with over 35 years of active development that has earned it a strong reputation for reliability, feature robustness, and performance. Although it was already an amazing database, it has recently been gaining even more attention as it has also shown promise in utilizing AI services through vector data types. About the installation, you can use the PostgreSQL download page. Or if you're using Mac OS, you can install via Homebrew. Or if you are using Windows, you can use winget. For Linux user, you know what to do. To demonstrate how to leverage a variety of database management tools, we will create a new database in PostgreSQL from the terminal. Then execute the commands to create and populate the database schema in pgAdmin 4, the most popular and feature-rich open-source administration and development platform for PostgreSQL. Start the PostgreSQL through the terminal. Create a new database named BTYT Ktor DB in snake case. To ensure flexibility and repeatability, we are taking an approach that allows us to start from scratch every time. If the task table already exists, we will recreate it. This enables us to run our script multiple times without worrying about the table's existence. We'll create a single table named tasks with 3 columns: name, description, and priority. These column names match the corresponding properties of the task class, making data mapping straightforward. Additionally, we'll include an ID column of type serial, which will automatically assign unique integer primary keys to each row based on the database settings. Run the following SQL commands against the database in pgAdmin 4. In Kotlin, the use of coroutines offers a convenient solution for asynchronously executing database queries, thereby preventing thread blocking and ensuring responsive handling of HTTP requests. Open the task repository.kt file in source main Kotlin model. Add the suspend keyword to all interface method. This will allow implementations of the interface methods to start jobs of work on a different coroutine dispatcher. Since we modified the interface's method signature, the derived class's fake task repository method signature also needs to be changed. So far, we've established the foundation for implementing the Postgres task repository, which will enable asynchronous execution of database queries. Okay, now let's do the connection setting. Go to the databases.kt file in source main Kotlin. Inside the configure databases method, use the database.connect function to connect to our database. The data access object pattern separates the client interface of a data resource from its underlying access mechanisms, allowing for easier modification or replacement of data resources without affecting the application's business logic. Adaptation of specific data resources access APIs to a generic client interface. Independent change of data access mechanisms without impacting the code that uses the data. Object-relational mapping is a programming technique for converting data between a relational database and the memory of an object-oriented programming language. There are pros and cons about ORM. My thoughts: pros are it can boost development speed once you get familiar with it. Type safety and language syntax can help prevent SQL injection attacks, and provides convenience in relation to writing on the vendor-specific SQL differences. On the other hand, cons are you need to learn how to program with ORM, since it needs additional steps to translate between functions and SQL queries. It is relatively slow, and from time to time you need to customize querying functions against the complex SQL query. Good. Now we know the concepts. Let's use them. Open the build.gradle.kts file and add the following dependency. In IntelliJ IDEA, navigate to the right edge of the editor and click on the Gradle notification icon to update any related Gradle changes. Go to source main Kotlin and create a new package called db. Inside the db package, create a new mapping.kt file. Open mapping.kt and add the types task table and task DAO. These types utilize expose to establish a connection between the properties of the task type and the columns in the task table within the database. The task table type serves as the foundation for this mapping, while the task DAO type enhances it with additional helper methods for performing create, read, update, and delete operations on tasks. Let's continue implementing the helper functions. Suspended transaction takes a block of code and runs it within a database transaction through the I/O dispatcher. This is designed to offload blocking jobs of a work onto a thread pool. DAO2Model transforms an instance of the task DAO type to the task object. At the time of making this video, exposed library R2DBC supporting seems still working in progress, which makes us hard to harness full potential of asynchronous non-blocking programming. There are several decent alternatives out there with R2DBC support, for example Zook. We are also going to deal with R2DBC and reactive programming on this channel, but in today's session, let's focus on the DAO pattern, ORM, and how to apply it. We have everything needed to create a database-specific repository. Navigate to source main Kotlin model and create a new Postgres task repository class. In there, we are going to implement the helper method of the task DAO and task table types to interact with the database. Having created this new repository, the only remaining task is to switch to using it within our routes. Okay, now let's finish the job. To switch to an external database, all we need to do is simply change the repository type. Open the application.kt file in source main Kotlin. In the application.module function, replace fake task repository with Postgres task repository. When we inject the dependency through the interface, any changes to its implementation don't affect the code that manages routes, making it more flexible and maintainable. Run the app and access to localhost port 8080/static/index.html. The UI remains unchanged, but it now fetches the data from the database. To verify this, add a new task using the form and query the data held in the tasks table in PostgreSQL. Great! With this, we have successfully completed integrating a database into our application. As the fake task repository type is no longer needed in production code, we can move it to the testing source set in source test Kotlin. Today, we have integrated an external database into our application. And through the code along together, we got a hands-on experience to form a 3-layer architecture using the Ktor framework and database. It's fun to learn new things, but next time, I'd like to try something new to create some fun.